called sequential. Let's crack the code here. Means two or more reactions in sequence. And so what they mean is we're going to run the first reaction. So we're going to take carbon and we're going to react it with water. And usually this has to be done at high temperature, so the water is really steam to make this happen. And we get carbon monoxide and we get hydrogen gas. That's going to be our first, and let me label that as our first one. And then our second reaction, we're going to take some nickel without looking up there. Is nickel monatomic or diatomic? Nickel, monatomic or diatomic? Monatomic, okay, need to know that kind of stuff. We're going to react it with the carbon monoxide, and we make this substance called nickel tetra. Tetra meaning 4, carbonyl. Let me give you the scenario here. Why would we do this? We work for a chemical company, and our company wants to make this substance to go sell. In fact, there is a company here in the Houston area that makes this stuff. A few years ago, they had a bad leak of it, and they had to evacuate the building and the surrounding houses, because this stuff isn't real nice. Nickel. A lot of people have allergies to nickel. So if you have earrings that have a nickel alloy in the post, sometimes you have a bad allergic reaction to it. Or even a watch band, if there's nickel in the alloy, you can have a big reaction here and have your skin break out. So this stuff is nasty, and this could be nasty. Okay, so here's our setup. We want to make this to sell. We have a source of nickel. Okay, we have a choice about the carbon monoxide, that we could buy it from another chemical company, and they would charge us probably way too much. Okay, and also it's a toxic gas. So if we buy it from another company, we have added charge, plus we got to store this stuff, which means we've got to dedicate a part of our plant to storage of the gas cylinders of a toxic gas. So you've got a safety issue, you've got a storage issue, you have a cost issue. And so what a lot of companies do, hey, let's make our own CO. And so we're going to start with carbon. No problem there. It's cheap. We can get hold of it. Water, no big deal. It's abundant, at least so far, that we could make our own. Now this is a byproduct, but hey, you could collect it and go sell it as a little side product to sell. So what we want to do is make this, and then we're going to turn right around, immediately use it. So we bypass the big cost issue. We bypass the storage issue. And if this is all in a sealed up place, we bypassed having the toxic gas sitting around in cylinders that could leak over time. So, what we got, 2 weights. We do one, then we do the next one. So nothing really new, it's just we've never done it this way before. You have done 2 before, but it was limiting and excess, and you did it with one equation. But I want you to see how similar this is. Okay, what do they say? We are going to start with 75 grams of carbon. We have excess water. That's good. Excess is code for don't worry about the water. What we need to do is we need to find out how much we can get. We're going to assume life is perfect. We're going to get 100% yields. So let's call this X moles. Now you could go to grams, but my choice, let's go moles, and I think you'll see in a moment why that's a good choice. So let's just work this first problem. Forget about this second. So this is just review of a weight problem. Okay, so over here, we just need 2 sets of parentheses because we're going to moles of CO. Okay, from this, where do we go? What shall we do? Nina?
Are you putting the 75 grams in there divided by the formula weight?
And it is?
12.
12. And instead of saying formula weight, you really should have said
Grams per mole. Atomic weight.
atomic weight, yeah. Okay, so the grams cancel. And then we have to think about mole ratio. So Pedro, what's the mole ratio?
1/1.
Just 1/1. And I'm going to start getting lazy here about units. And that's going to tell us how many moles of CO we make. So let's do this division. Okay, and what are we getting here? Russell, what'd you get?
What? 6.25.
What did Pedro get, huh? 6.25 moles of CO. Okay, everybody got that? All right, then, the unknown here is going to turn into the known down here. So now we have 6.25 moles to go on with. This is my unknown. Now, look at this. This is my unknown, and usually I call the unknown X, but since I used X up here, I'm just going to call that Y. And I'm going to say we get Y grams. Call it X prime. I don't care what you call it, but that's the unknown for the second time through. Okay, we're ready to roll. This time I want you to go all the way to grams. Okay, now, how about in this first set of parentheses, Antonio, what do I put?
The 6.25.
Okay. Is that okay the way it is, or should...
Over the formula weight of this.
Okay, I'm suckering you into something.
It's already moles.
Why does he not want to divide by the formula weight of CO?
It's already moles.
It's already moles. And that's going to be a big mistake that people will make on testing. Today, there's no penalty, Antonio. That's fine. I'm glad you did it. Because I want to reinforce the idea. Watch the units. If they're moles, slam it in there. If they're grams, then do what Antonio said, divide by the formula weight. I don't know how many times I've seen students take this, or a problem like this, and then divide by the formula weight. Don't do it. You're already there. Okay, then we need a mole ratio here. Angel, what's that going to be?
1:4.
1:4. Good for you. Here's the understood 1. Here's the 4 right here, if you can read my writing. Okay, so 1:4. Then what am I going to need out here? Marco, what do I need out here in the last place?
You need the formula weight of
Okay, and do you have that?
working on it.
Okay. Russell, do you already have the formula weight of this? Nickel
Yeah,
tetracarbonyl?
it's 170.7.
170.7 grams per mole. Marco, is that what you got, or are you there yet? You got a nickel?
Yes.
Okay. Everybody okay with that? All right, then we'll put that out here, 170.7. And if I've been good about writing units, all units cancel except grams of that nickel tetracarbonyl. So let's punch that through. Let's see what we get. Prasant, do you have it? Do you have it punched?
266.7.
266.7 grams. Is that what other folks got? Okay. Now, in sequence or sequential, you will be given 2. It could be more than 2, but usually you're given 2. And what happens is you've got to spot what is the product over here that goes on into the second one. Does anybody have a question on this? Let me ask you something. Why did I have a stop at moles? Why didn't I go on to grams here this first time through?
So you can just...
Okay, Andrew, say it so everybody can hear.
You would
Why?
You wouldn't have to do grams over grams, you could just go straight moles and it cancels out the human error.
Okay, I think this is what you were saying, okay? All right. If I went to grams here, I'd have to come right back here and undo it and get back to moles. And so I think the first time I typed that stuff up, I was stupid enough to go to grams, and then you had to undo it and come right back to moles. So just stop at moles, move into there. Okay, everybody with that?